simple probability is not a big issue for you. Probability, like you guys have already seen, is we're talking about the probability of an event. Bless you. They usually label it with P and then something in parentheses. And the probability of an event is always the ways it can occur over total possible ways. Now, when you guys did those couple of problems yesterday where I think it was talking about, was it dice yesterday or was it cards? I think it was cards. When you're thinking about when with a deck of cards, yeah.
Okay. So number 14.
If you use the formula, if you build it out with the formula, you get 31 over 432. So in this case here, do you guys know that there's a parameter for probabilities? What's the low end of a probability?
0.
0. What's the high end of a probability? No, it's 1. Probabilities can't be larger than 1. If the probability is larger than 1, then it's wrong. If the probability is less than 0, it's also wrong.
It can be equal to 0 though? Oh, so you have a 0% chance of...
Correct. It's like you not having homework.
That's a 0% chance?
Correct.
Yesterday I did.
You having homework.
I
but
didn't
you-
have any yesterday.
2 days ago I had a 100% chance.
Yeah, so your probabilities are always between 0 and 1. That's one, I'm sure you guys already had known that. I just want to make sure you saw it. So yesterday when you did a couple of those card problems, the one example I think you might have had was, what's the probability of a jack? Well, how many jacks are there in a deck of cards? 4. So if you want to say the probability of getting dealt a jack, well, that would have been 4 out of the 52 total cards, which gives you 1/13. You always simplify your fractions. Calculator does the work for you in something like that. Just one of the quick things to remind you. Okay. So as you go through and you're working with probabilities, one of the things that we also use quite a bit with probabilities is using dice. And I was actually kind of impressed with the fact that this book actually used the word die. Most books use number cube because dice is evil. Don't know why, just is. Number cube. They call it a number cube.
What's that one game that you play with dice? It's like a cube and then you roll like...
Yahtzee.
No, not that
No,
one.
it's 10.
Something like that. You just take like 5 dice, roll it, and then there's this kind of like point.
Does it involve
That's Yahtzee.
There's like a trap.
Yahtzee. That's Yahtzee.
No.
So you have like 5 dice,
Yes,
and you have to get all the
it's
doubles and stuff like that, yeah. Fargo.
Yeah, I think.
You guys know it's a big game?
No, I know what Tyler's saying, it's not Yahtzee.
You go like this and are thinking perfection, so they gave you the dial, you put shapes in there before it pops out. What I want to look at here with you guys is there's 2 different types of probabilities. There's a probability called the theoretical probability and an experimental probability. A theoretical probability probability. Theoretical probability is something that numerically is what it should be. For example, if I'm rolling a dice, a single die, how many possible outcomes are there? 6. So the theoretical probability of rolling a 2 would be what? 1/6. So the probability of rolling a 2 would be 1 out of 6. What would be the probability of rolling an odd number?
3 over 6.
Yeah. Probability of odd would be 3 over 6, which is 1/2. Now, if I'm looking at here, what would be the probability of rolling less than a 7? 100%. Now, these are just your theoretical. These are what would be considered a theoretical probability. An experimental probability is a little bit different. For example, you have your dice, right? Thank you, sir. I'm going to use just one. Now, Tom happened to have dice because I guess he plays craps at lunch and he probably gambles a little bit, tries to keep people's money. What I want to do here is I'm going to do an experimental probability with one die. I'm going to roll it 6 times to get the sample size. Okay, so 5. 1. 3. I'll laugh if I get it. 2. Are you kidding me? 4.
6.
If I get a 6, we're going to Vegas. 1. 5, 4, 3, 2, 1. I had it in that order?
No.
5, 1, 2.
Oh, okay. And then I had another 1. So in this case,
So
this was
close.
my experiment out of 6. Okay?
Close.
So in this case, with my experiment, what's the probability of me rolling a 1? 1/3. See how it's a little bit different than a theoretical probability? Not by much, but it does wind up being a little bit different.
It's a way to dice.
So you see Tom at lunch, he's throwing dice against the wall like this, you know, he's taking money.
6.
That's impressive.
What is
Still going.
What?
Still spinning. 2.
Oh, then I get out.
So that's what we're looking at as far as the difference between theoretical and experimental. Does that make sense? Now, some of the things you will see that, I don't know if you can see that a lot in science you might, but
We did.
did you do some experimental things like that?
Yeah.
Oh. I guess I should have taught you about that before. Yeah, that's where you can get things like that. So, let's see. Let's look in, a lot of times in the math though, they do it off of a chart. You might see stuff like that.
Tomorrow.
I don't know if you see. I don't know. Never seen it.
Wait, the algebra one is hard.
I don't know.
You guys are gonna get so mad. They're gonna
Those,
get mad.
like the questions were
If I get confused, I'm just putting it in. I get
Oh,
confused,
tomorrow?
I'm just gonna play on the things that I've done in the
The non-calculator, I don't know, the practice non-calculator was only 8. And then the calculator portion, I think, was only 24. Which, I don't know if you saw some of the calculator questions. We should have a couple minutes here. I'll show you how to do weird ones here. So what happens here, if we're looking at theoretical probability, of course I've done that. You have races, you try to spark it? No.
You can do this.
Can you actually do it?
I'm gonna have my sister do it.
Me and my friends when we were
It used to be done? Anyway, what happens here is that you might see stuff like this, where they randomly select somebody out of a table. Guys, where they do a random selection out of a table, and they want to see what's the probability, according to the data that you have in front of you, that a person selected will be 24 years old or under. So what you're looking at here, you'd have to figure out your total sample size, basically adding up those 4 values.
and then divided by 9.
Yeah, divide by which one does that fall into. So if you're looking for the persons between 24 or under, you know, your desired outcome would be the 94,507 divided by the sum of all of these. Okay? You see that a lot of times with data. Okay? They're going to look at a data set and find the probability that a certain thing occurs within a data set. That's what that happens. Okay?
Answer is 0.353116.
Very good. Well, that leads us to geometric probability.
When you play paper airplane, target prices.
Don't you remember what geometric probability was?
Oh, this sucks.
Sucks.
We went over it for like a day-ish and never brought it up again. And it was
Geometric probability is the,
Stupid.
it's not stupid, it's the favorable area
over the end.
over total area. It is not stupid. Geometric probability is quite fun. For example, if I wanted to find the probability that I hit the bullseye, what would you do to find the geometric probability of hitting the bullseye?
You take the area
Find
of
the
the,
area of
like,
the bullseye and
of
then
the entire.
Oh,
You
No
said not.
way.
Yeah.
that's way better than paper airplane.
Gotta say,
I was about to
that
make-
string doesn't look too tight. That's cool.
What's going to be the geometric probability that if we're going to get a bullseye?
The total, the area of the bullseye over the total area of the
All right, what's the area of the bullseye?
Three.
It's okay.
3 pi r
3
squared.
pi.
So,
Make sure that.
Oh.
Hooray!
Again.
Try and clone it.
well, not yet, so like, get the shadow.
More fun when we have sound effects. You guys didn't have this kind of fun in your geometry class.
Oh, we had thought. Yeah, from when he dies.
So far, I'm not doing too well.
You have 1/4 chance.
You're gonna get you there, don't you?
1/4 pi chance.
Oh, pi divided by pi is?
1.
Mm-hmm.
You gotta go to the right.
You're pulling them left.
Pulls left, I know.
What happens if you hit the bullseye?
I'm trying. Cool things, man. Cool things happen, believe me.
Fireworks.
Oh,
Fireworks.
All right, according to
Solitaire went.
This is the greatest day ever. Booby again. Is there It gets to be a little much after a while. You don't get this kind of entertainment in your other classes, do you?
aim to the right.
That was probably.
I try to tell jokes too, it just doesn't work.
Right.
I'm trying.
Yeah! Well, you split an arrow.
Kinda.
Which is the area you're trying to hit?
I'm trying to get the bullseye. It's really awesome.
You like the red?
I'm just gonna go up there in a minute here and hit it.
Just pull it right, just go win.
Obviously, the probability is not that good.
It's not that good, right?
Ah!
Oh, come on!
I am the champion. I am the champion. No time for losing, 'cause I am the champion of the world.
He went 10 IU.
Yes, he did. You don't get this kind of entertainment every day, I
The
know.
guy who,
Every once in a while, we try to have some fun. So if I want to find the geometric probability of landing in the shaded region,
Oh no, apothums.
No.
We actually
No.
have to do.
Apothums. I
Run.
don't remember how to do it. It's like.
No,
if I want to go through, oh, and all that was on tape too. I just recorded that whole thing. That was kind of boring. Center to the side, the center. You guys remember the apophyum, perimeter apophyum stuff?
No.
I always called it an apophyum. I don't know. People call it an apophyum, apophyum. So the area of a regular polygon is 1/2 the perimeter times its apophyum.
That is cool.
The apophyum is from the center, drawn to the side, and it's the perpendicular bisector of a side. When you take from the center to the vertex, it's also a radius. Okay? It bisects the angle of the regular polygon. So in a hexagon, all the angles are the same, a regular hexagon. And do you remember how to find each angle? N minus 2 times 180 divided by n gives you 120 on all the angles. So I bisect it and I get a 60.
This was the area
So
you
you get 30, 60, 90.
It's gotta be easier.
So in this case here, you will notice that this becomes an 8. Across from the 90 gives you another 16, which means your apothem would be 8√3. So to find the area of the shaded region here, that's my favorable area. First thing I would have to do is take the area of the circle and then subtract out the area of the regular polygon. Well,
Is the area of the circle just 2 apothem?
No, the circle has a radius of 16.
Oh, okay.
Because when you do the 30, 60, 90, if the 8 is across from the
Oh.
30 across from the 90 is 16.
Yeah.
So your circle would be 256 pi, subtract 1/2 the perimeter, 8 times 16. Oh, not 8, 6 times 16.
Radius squared.
Pi r squared. And 8, yes, this is geometry. But we're talking about probability.
I hated this.
Put a 1 over it.
So that is your area of the shaded region. But if I want to find the geometric probability of landing in that shaded region, I have to divide it by the total area, which is the circle. So this is a nasty looking thing, but you could, if you use your alpha y equals button with a fraction bar, you can type that in exactly the way that it looks, and you'll get the answer. Okay? Yes, sir.
What is it? Doesn't that say area?
Yeah, area of a regular polygon.
Oh.
It's a reg. Come on, my handwriting's awesome. Yes, sir.
We should do the experimental probability of
Oh, if I would hit the board or hit you?
I mean,
You can just stand there and see if I hit you or hit the board.
I would love that.
That'd be pretty
What do
funny.
you put like the apple on his head?
What if I had my glass on and just stuck? That'd probably be glass.
Yeah, that's right. If we do that, we put it. I have an apple.
Who's brave enough to get under it?
Where's Bomber? Oh, he's not here. It is really quiet. It's kind of nice.
I am 103.
So what I wanted, because what time? We're done out of here pretty soon. Let's do this.
Is point 17 3?
Yeah, it's a small grouping here. What I'd like to do here is I'd like you to do on page 719. (12 through 34). I think that's good enough for now. Yeah, 12 through 34 and 719. Now, granted, we probably won't be collecting or going over any of this stuff until next Monday. So you get the idea that it's going to take a while to get through, because with all the other stuff. So 719, 12 through 34. Oh yeah, so it'll be next Tuesday. Jeez. You can do like 2 problems a day for the next couple of days. Yes, sir. Yes, sir?
How often do you test your telekinesis powers to see if you have it? Or did you used to? You definitely have. Don't look at me like it's crazy.
Here's an apple. Who wants to sit underneath it? We can try and shoot it off your
Okay.
head.
I got it. I'll do it. I got it.
Mr. Murphy.
Yes, sir.